We're given f of x comma y and asked to find the partial derivatives. We first have the partial derivative of f with respect to x, and then the partial derivative of f with respect to y. To determine the partial derivative of f with respect to x, we'll consider y a constant and differentiate with respect to x. And then to determine the partial derivative of f with respect to y, we'll consider x a constant and differentiate with respect to y. So for this first partial with respect to x, we're treating y as a constant and differentiating with respect to x. So the derivative of negative 2x to the sixth with respect to x would be negative 12x to the fifth, plus for the derivative of 6xy squared, we're treating y squared as a constant and differentiating with respect to x. The derivative of 6x would be 6, so we have plus 6y squared. And then the derivative of 5y to the third with respect to x would be 0, again because we're treating y as a constant. So this would be the partial derivative with respect to x. And now for the partial derivative with respect to y, we're treating x as a constant and differentiating with respect to y. And therefore the derivative of negative 2x to the sixth with respect to y would be 0, again because x is a constant, and then plus the derivative of 6xy squared with respect to y. And since the derivative of y squared is 2y, we'd have 6x times 2y, or 12xy, and then plus the derivative of 5y to the third with respect to y, which would be 15y squared. This would be the partial derivative with respect to y. But before we go, let's quickly review what these functions will tell us about the function f of x comma y. The first partial derivative of a function of two variables tells us the slope of the tangent line at a given point in either the x or y direction based upon which partial derivative. This will measure the rate of change of z, or the function, with respect to x, or the rate of change of z, or the function, with respect to y, again depending on which partial derivative we're referring to. I hope you found this helpful.